The data was supposed to confirm what astronomers already believed. A routine survey of the outermost reaches of the solar system, a catalog of distant frozen worlds drifting quietly in the dark. Nothing dramatic, nothing unexpected. Then the numbers came back wrong. Several small worlds far beyond the orbit of Neptune, objects that had no reason to behave the way they were behaving, appeared to be clustering in the same region of space. Their orbits were tilted in the same direction. Their paths through the solar system were bending toward the same invisible point. That shouldn't happen randomly. The laws of orbital mechanics make that clear. For those anomalies to exist without a cause, the probability is less than 1 in 1,000. Something is out there, something that hasn't been seen yet, something large enough to bend the trajectories of distant worlds and pull them into alignment across billions of kilometers of empty space. The problem is that no one has found it. What you are about to see is not a settled question. It is an open investigation, one that has divided the astronomical community, challenged existing models of how the solar system formed, and forced scientists to confront a deeply uncomfortable possibility: that after centuries of observation, there is something significant in our own cosmic neighborhood that we have simply never detected. The outer solar system is enormous. Distances there are measured not in kilometers or even millions of kilometers, but in astronomical units. The average distance from Earth to the Sun, and even at those scales, something appears to be leaving a gravitational fingerprint on the objects that surround it. What is leaving that fingerprint? Is it a planet? A large, undiscovered world on a vast, slow orbit, so far from the Sun that it reflects almost no light? Is it something else entirely? Or could the entire pattern be an illusion, a trick of incomplete data, a bias in the way astronomers select which objects to study? Each of those possibilities carries consequences, and each one, in its own way, is extraordinary. To understand what is disturbing the outer solar system, you first have to understand what lives there. Most people picture the solar system as 8 planets and a belt of asteroids, clean, ordered, compact. But that image covers only a fraction of the actual territory our sun governs. Beyond Neptune, the last of the known planets, begins a region called the Kuiper Belt. It stretches from roughly 30 astronomical units from the Sun to around 50. Within it drift hundreds of thousands of icy objects, remnants of the material that built the solar system, preserved in the deep cold like fossils from the beginning of time. Pluto is one of them. It is not an outlier. It is simply the most famous member of an enormous family. But even the Kuiper Belt is not the edge. In 2003, astronomers discovered an object unlike anything they had encountered before. They named it Sedna. Sedna is small, perhaps 1,000 kilometers across. But its orbit is extraordinary. At its closest approach to the Sun, it comes no nearer than 76 astronomical units. At its farthest, it recedes to roughly 940 astronomical units before swinging back. Its full orbit takes approximately 11,000 years to complete. That distance placed it far outside any known gravitational interaction. The planets couldn't have put it there. The Kuiper Belt couldn't explain it. Even the theoretical cloud of comets at the outermost edge of the solar system, a vast spherical haze known as the Oort cloud, didn't adequately account for Sedna's behavior. Sedna was, in the language of orbital dynamics, anomalous. And Sedna was not alone. In the years that followed, more objects were found in similarly extreme orbits. Trans-Neptunian objects, scientists called them, a broad category for anything orbiting the Sun from beyond Neptune. But a specific subset of these objects, the ones with the most distant elongated orbits, began to reveal something troubling. They appeared to be moving in a coordinated way that chance alone could not explain. And when astronomers finally measured exactly how coordinated, the number they got back was not comfortable. Every orbit in the solar system has a shape, a tilt, and a direction. The direction tells you which way the object swings closest to the sun. And in a system governed only by the 8 known planets, that direction should point randomly across the sky for each object. No coordination, no pattern. Just the accumulated chaos of billions of years of gravitational scattering. There is no physical reason for distant, unrelated worlds to point in the same direction. In 2016, astronomers Konstantin Batygin and Mike Brown published a paper that changed the conversation. They had analyzed the orbits of 6 of the most extreme trans-Neptunian objects, bodies with the widest, most elongated paths around the sun. And what they found was deeply strange. All 6 objects had their closest orbital approaches pointing in roughly the same direction. Their orbital planes were tilted in the same direction. They were physically grouped as if something had herded them into position and held them there. Batygin and Brown ran the statistical analysis. The probability that this alignment occurred by chance? Approximately 0.007%. Not 1 in 100, not 1 in 1,000, roughly 1 in 15,000. Let that number settle for a moment, because that is not a curiosity. That is not a fluke. That is what a signal looks like when it is trying to be noticed. The question was, what was sending it? To be clear about what this means physically, these are objects separated by enormous distances, orbiting a star on timescales of thousands of years. For them to share these orbital properties, they would need to have been influenced by a gravitational source that has been acting on them for an extended period of time, not a brief encounter, not a random nudge, a sustained, systematic force. And if that force was gravitational, there had to be a mass producing it. Batygin and Brown had a candidate, and the name they gave it would change the conversation in astronomy for the next decade. Batygin and Brown proposed a hypothesis. They called it Planet 9, not a discovery, not a confirmed observation, a mathematical prediction. The kind that has changed astronomy before, the same kind of reasoning that led to the discovery of Neptune in 1846, when astronomers noticed that Uranus was not moving exactly as it should, calculated the position of whatever was disturbing it, and pointed a telescope at that spot in the sky. What they found was a planet no one had ever seen. Batygin and Brown believed they were looking at a similar situation. Their calculations suggested that the orbital clustering of the extreme trans-Neptunian objects could be explained by a single massive body, a planet perhaps 5 to 10 times the mass of Earth, orbiting on an extremely elongated path with a period of 10,000 to 20,000 years. If it exists, Planet 9 would be a world unlike anything else in our solar system, cold beyond any human reference point, dim to the point of near invisibility, perpetually distant, spending the majority of its orbit hundreds or even thousands of astronomical units from the sun. At that distance, it would reflect only a tiny fraction of the sunlight that illuminates planets closer to home. Finding it would require pointing a powerful telescope at exactly the right patch of sky. And that patch of sky, given the uncertainties in the calculations, is enormous, perhaps an area covering thousands of square degrees. Astronomers have been searching. Surveys have swept large portions of the sky. So far, nothing matching the predicted profile has been found, but absence is not refutation. The outer solar system is vast. The darkness is nearly absolute, and the object, if it exists, could easily still be hiding in regions not yet surveyed with sufficient depth. The prediction remains open, but there was a problem, several in fact, and they were serious enough that some astronomers began to wonder if the entire hypothesis had been built on shaky ground. Science, by its nature, demands skepticism, and the Planet 9 hypothesis has attracted serious scrutiny. One of the most significant challenges comes from observational bias. The extreme trans-Neptunian objects used in Badigan and Brown's original analysis were not discovered uniformly across the sky. They were found in specific patches of sky using specific telescopes during specific survey campaigns. And because those surveys were not random, the objects they found may reflect the observational footprint of the surveys themselves, not a real physical clustering. In other words, astronomers may have found these objects in roughly the same direction simply because that is where they were looking. The clustering might be, at least in part, a statistical artifact. This is not a dismissal. It is a serious scientific concern, and Badigan and Brown have engaged with it directly, arguing that even after accounting for observational bias, a statistically significant signal remains. But the debate is unresolved. Other researchers have raised independent challenges. Some have argued that the same orbital patterns could be produced without a single massive planet, that the combined gravitational influence of the many smaller objects in the outer Kuiper belt, acting collectively over billions of years, could mimic the signature attributed to Planet 9. This is called the self-gravity hypothesis. It is technically demanding and statistically complex. Its proponents do not claim certainty, but they argue it cannot be dismissed. Then there is a more fundamental problem. Models of how the solar system formed, how planets grew from dust and gas and ice around a young star, do not naturally produce a planet of the mass and orbit predicted for Planet 9. If Planet 9 exists, it likely formed closer to the Sun and was then ejected outward by gravitational interactions with the other giant planets. Possible? Yes, but the sequence of events required is specific enough to give some theorists pause. None of these objections have killed the hypothesis, but they have kept it honest. The mystery has not simplified. It has deepened. Here is where the investigation opens into something larger, because Planet 9 is not the only explanation that has been proposed for the anomalous clustering, and some of the alternatives are, in their own way, even more unsettling. One hypothesis, advanced in recent years, involves not a living planet, but a dead one. In 2019, astronomers Jakob Schultz and James Unwin proposed that the gravitational signature attributed to Planet 9 might instead be produced by a primordial black hole. Primordial black holes are theoretical objects, remnants, if they exist, of quantum fluctuations in the extreme density of the very early universe. They would be extraordinarily small by cosmic standards, potentially no larger than a grapefruit, but with a mass equivalent to a large planet. If one were drifting through the outer solar system, gravitationally bound to the Sun in a distant orbit, it would be essentially impossible to detect directly. It would produce no light. It would reflect nothing. Its presence could only be inferred from its gravitational effects on the objects around it. Schultz and Unwin's paper was not a confident announcement. It was a mathematical exploration of whether the data was consistent with such an object. The answer they found was yes. But that answer does not make it likely. This idea circulates widely online, often presented as something more settled than it is. It is not a leading explanation. It is a speculative possibility that the mathematics does not rule out, which is a very different thing. Whether that possibility is real remains deeply uncertain. There is another avenue of inquiry that has gained traction in recent years. Astronomers have used newer, more comprehensive sky surveys, datasets that cover the sky more uniformly, reducing the risk of observational bias, to reanalyze the clustering question. The results have been complicated. Some surveys appear to confirm the clustering, at least in part. Others reduce it significantly. The signal is real enough that it cannot be dismissed, but not strong enough that it closes the debate. What this means is that the investigation is genuinely ongoing. The data is still being collected, the analysis is still being refined, and the full picture of what inhabits the outer reaches of our solar system has not yet come into focus. There may be a large planet on an enormous orbit, gravitationally shepherding smaller objects into patterns that have taken decades to notice. there may be something stranger, an object that emits no light and can be detected only by its gravitational shadow. There may be a combination of effects, bias and self-gravity, and incomplete surveys that together explain the anomalies without invoking anything undiscovered at all. Or there may be something that current models have not yet imagined, something that awaits a name. The Vera C. Rubin Observatory in Chile, one of the most powerful sky survey instruments ever built, is now in the process of mapping the entire accessible sky repeatedly, to a depth far beyond what previous surveys achieved. Over the coming years, it is expected to discover thousands of new trans-Neptunian objects, and in doing so, either confirm or seriously challenge the orbital patterns that launched this investigation. If Planet 9 exists, the statistical weight of that larger data set may finally point precisely enough to allow targeted searches. If it does not exist, the patterns may dissolve into noise as the observational biases are corrected. Either outcome will be instructive. Either outcome will change the picture. Begin at the beginning. Several small worlds in the outer solar system are moving in ways that do not accord with what astronomers expect from a system shaped only by the 8 known planets. Their orbits align, their perihelions cluster, the numbers resist coincidence. That is the observation. The explanation remains, genuinely and verifiably, unknown. Maybe Planet 9 exists, a cold, slow world in a vast orbit, hiding in a darkness so complete that its existence has had to be inferred from the shadows it casts on smaller objects. Maybe it formed close to the Sun billions of years ago and was ejected by gravitational chaos during the violent early history of the solar system and has been drifting outward ever since. Maybe the explanation is something far stranger, a primordial black hole the size of a grapefruit, orbiting the Sun in the frozen dark, detectable only by what it does to the space around it. Not a planet, not a remnant of formation, something older and more fundamental than the solar system itself. Maybe the signal is partially illusory, a pattern shaped by the instruments used to search for it, by the limited patches of sky that have been surveyed, by the small number of objects on which the statistics depend. Maybe the outer solar system is less ordered than it appears, and the mystery will dissolve when enough data arrives to replace inference with observation. Astronomers are still looking. The surveys continue. The catalogs grow. The models are refined and challenged and rebuilt. What they know with certainty is that something unexpected is happening in the outer reaches of the solar system. The orbital record is real. The statistical improbability is real. The absence of a confirmed explanation is real. And until a telescope finds what, or finds nothing, the question that Sedna first posed more than 2 decades ago remains unanswered. Something disturbed those orbits. What it was has not yet been found.